this morning in our case study presentation series is by Stephen Johnson, who's going to be talking to us about coral reef resilience to climate change in Saipan's CNMI, field-based assessments and implications for vulnerability and future management.
Good morning, Hafaday everyone. My name is Stephen Johnson and I work as a coral reef manager for the Division of Environmental Quality in Saipan in the Commonwealth of the Northern Marianas. I'm presenting on behalf of a larger team of local management agencies who work closely with NOAA and the Nature Conservancy. And this morning I'll be describing some recent field-based assessments of the resilience potential that we conducted and the implications of that work for current and future management planning. So first I'm going to start off by providing you with some background on the CNMI and its coral reefs. We're kind of, I like to say, America's best kept secret. And I'll tell you why we conducted this field-based assessment, and then the variables we measured and assessed, how we used these results to inform management, and also describe some of the products that we've got coming out. So I was born and raised on the island of Saipan, which is a part of the Commonwealth of the Northern Marianas, which is a U.S. territory. We're part of the Marianas Archipelago, which also consists of the territory of Guam, which is making a lot of news nowadays with Korea. The CNMI itself has a population of about 50,000 people, but 90% of that population lives on the island of Saipan. We've got a wide variety of reef habitats, and although we're part of Micronesia and maybe not as well known as, say, Chuuk for the World War II wrecks or Palau for all of its amazing diving, we do have a lot of great habitats to offer. One thing is our visibility in the water. A bad day for us is about 100 feet viz. So if that sounds like fun for you, you should definitely come visit us. And like most of the other island communities in the Pacific, coral reef management is a huge priority. For example, we've got about 5 MPAs and a lot of fishing gear method regulations, which the community has helped develop. And coral reef management itself is kind of a unique situation we've got in Saipan and the CNMI, because unlike most of other Micronesian cultures, we don't have a lot of that traditional management intact. The islands have been under hundreds and hundreds of years of colonial rule, so it's a very Western system. And that compounded with being a U.S. territory is you have that more formal government structure where we get funding and the agencies are really in charge of managing the resources. But that hasn't really stopped us from working with the local community. We do partner with 2 of our primary NGOs, and they've been giving us a lot of support. So now we're going to get into the meat of this talk is this field-based resilience assessment and why we did it. So like coral practitioners and managers all over the world, we know and understand that climate change is the single greatest long-term threat to our coral reefs. We want and we need to really implement and maximize the ability to use resilience and to enhance that natural resilience that coral reefs have. So for this project, our overarching objective was to assess the spatial variability and reef resilience potential so that resilience information can become a consideration in management planning. And underneath that overarching objective, we had 5 kind of main themes that we wanted to get at. And the first one would be to assess the resilience potential for reefs already within protected areas and to assess the anthropogenic stress in those areas. Second, to identify areas with the greatest relative resilience to consider for inclusion in new protection. Third, to identify areas especially vulnerable to bleaching, so those communities that have a combination of bleaching susceptible coral species and low herbivore biomass. Fourth, to identify areas with the greatest and least exposure to pressures related to human activity, so those places that might have impaired water quality or high fishing pressure. And last, to identify areas with higher relative resilience that also have tourism value potential due to their condition and diversity. So yesterday, we kind of touched on this, how this has been a pretty exhaustive process over the last decade of figuring out how do we assess reef resilience. And we've heard, like Darta said, they had 60 variables that they use. Other people have been using 30 variables. Fortunately for us, we got do this assessment with only 11, something very feasible, easy to do, and also it's a lot of stuff, a lot of parameters that our local monitoring programs have already started to collect data on. So quickly going through our list, these are the 11 that we've decided to go through, which are bleaching resistance, temperature variability, coral diversity, herbivore biomass, coral disease, macroalgae cover, coral recruitment, nutrient input, sedimentation, physical human impacts, and fishing pressure. In the final, you'll see this later in this presentation, but in the final analysis, we didn't end up using all 11. We only used 9 because we didn't find any significant coral disease or physical human impacts at most of the survey sites. The field work for this was done about a year ago, so March through May of 2012. So quickly, this map shows you 35 sites that we surveyed around Saipan, and we got real good spatial coverage around the island. So each site is roughly about 1 mile apart, with the exception, of course, being on the eastern side of the island where it's most of our wave exposure. There's not a lot of good reef development on that side of the island. So now we're going to get into the data collection side of things. This is a subset of our data. Again, we did 35 sites, 9 variables, but for the presentation, we've just picked out some of the top sites. And we've got 2 tables up here. So the top table has our raw data. So it's the raw scores for each of the 9 variables that we're using for the assessment. And on the bottom table, we have those scores after they've been anchored and normalized. And we basically took this process and for this presentation, we want to simplify it so it's easier to share with everyone. And we've broke it down into 4 steps. So the first step is taking those raw data values for all the sites and anchoring it to the max value of that parameter and normalizing it to a unidirectional 0 to 1 scale. So it sounds pretty complicated, but it's basically taking your highs and lows, making it a 0 to 100 scale. So you have your highest and lowest values, and we want to make it unidirectional so that 1 always meant that it was good. So for some of our variables like macroalgae cover, you would flip that so that a 1 didn't mean you had a lot of macroalgae cover, but a 1 meant you had minimal macroalgae cover. So next, all of our scores were then averaged. And then the final scores were then also anchored to a maximum score. So this gives us the resilience potential relative to the high and low values. And last, what we did was we ranked the sites from highest to lowest. So with our 35 sites, we were able to get a good spread, enough to see that there is a relative difference around for the reefs around the island. So sites with a score of 80 to 100 were considered to have high resilience potential. Those with 60 to 79% of the max value had a medium resilience potential, and anything below 60% was considered to have low. And we really want to get this scale down so that we could inform local scale management decision making with resilience potential as expressed relative to sites within the management area only. I know this came up yesterday in a question of your high score being only the best that you've monitored or surveyed. And again, it's really looking at what your management priorities and your questions are. So after we went through all of that analysis, we've came up with these 2 fairly simple products that are really easy for managers to use. So the map on the left shows each of the 35 sites with their score of either a high, medium, or low resilience potential. And then on the right, what we've done is we've used ArcGIS to create this kriging product, which is a spatial interpolation of those points. So it kind of fills in the blank spots between each of the survey sites, and we felt comfortable doing that because of how much spatial coverage we got around the island. And also, while you were in the water, you kind of saw that things didn't change too much around the island so that you could fill in those gaps, but again, there was enough difference in some of the sites to create a high, medium, and low ranking. Then another thing we did after all the data analysis was we had this big benefit from anchoring and normalizing the scores. And that's what it allowed us to do is we could do some more rigorous statistical analysis. So this example we're going to look at is a principal components analysis. And the beauty of that was that we were able to really figure out what factors were driving the sites that had high resilience potential, and which were the sites, or what factors were driving sites that had low resilience potential. And we found that the variables with the greatest variability, or the ones that are driving the model the most, were coral diversity, bleaching resistant species, herbivore biomass, fishing access, and macroalgae cover. And this graphic on the left shows sites that have high, or photographs from high, medium, and low sites. And it's a really strong graphical presentation that we can use with the community and with reef managers, showing that sites that have high resilience potential, you see they have nice corals, not a lot of algae cover. And then sites that have low resilience potential are typically monospecific and are bleaching susceptible, or have high macroalgae cover. So now I'll show you some maps that explain the management relevance of our efforts to map resilience potential. First, we want to, just going back to those 5 questions that we wanted to answer. And first was to assess the resilience potential of reefs already within protected areas, to assess the anthropogenic stress in these areas. So this map has 2 circles around 2 of our protected areas. So it was really exciting to see that the protected areas were places that had high resilience potential. And part of that was some of the factors that help you decide where you want to put your protected areas are also things that went into our assessment. Next, we want to identify areas with the greatest relative resilience to consider for inclusion in new protection. So these circles, these areas that are circled are places that do have high resilience potential, but currently they're not under any form of management. Third, we want to identify areas especially vulnerable to bleaching. So these are places that, again, have a combination of bleaching susceptible coral communities and low herbivore biomass. And these 2 circles represent those areas we found, and those areas are they're places in our shallow lagoon, and so they're typically monospecific stands of Acropora, and they also have high access for fishing, so it's easy to get there. Fourth, we want to identify areas with the greatest and least exposure to pressures related to human activity, so places that had good water quality and low fishing access. So again, these are areas that are typically harder for you to get to if you're a fisherman, and also have low development in the watershed. And then lastly, I want to identify areas with higher relative resilience that also have tourism value potential due to condition and diversity. And we found that a lot of the reefs on the southern part of the island fit that bill. So here's a picture of managers back in Saipan discussing our results. And through the whole process from planning, figuring out the sites, the whole survey methodology, managers have worked very closely with the researchers on this project. And more evidence of that is one of our PIs was Jeff Maynard, and he's here at this conference working with me on all of this stuff. So it's really a strong collaborative effort that we wanted to drive home from the get-go of this project. So here are some of the result outputs we've produced to include in our project report. The project report itself is available on Conservation Gateway. We've also put together some site summary report cards, which have been an important communication tool. So these are nice little cards that have full color photos of the site, description of the site, where it's at, maybe some interesting local knowledge about the area. It also has the score for each of the different variables, and this is really useful for managers because then you can see where you might get your bang for your buck if you want to improve condition at this site. We all know that we have limited funds to do a lot of this big work, so really being able to prioritize those efforts was key, and these report cards really help with that. Third, there was a how-to guide for reef resilience assessments produced in conjunction with the Nature Conservancy. And lastly, publications. One on approach is out, others on our results and process are forthcoming. We don't have physical copies with us, so we're trying to be green, but if you would like some, we could definitely email those to you. So I definitely like to acknowledge all the people that worked on this project. Like I said at the beginning, it was a really big collaborative effort. So it wouldn't be possible, especially without the help of Jeff Maynard and our other PI, Steve McKagan, back in Saipan. But there's a long list of other people who helped us, so I want to say thank you to them. And of course, thank you to the Nature Conservancy, who helped fund some of this project, and they flew me out for this presentation. I really appreciate it, and also to the museum for hosting us today. Thank you.